Hey guys, welcome back. So today we're going to be looking at some fractional equations. And we're going to be looking at questions that look a little bit like this one here, where we have a lot of fractions in a fraction and we're still trying to find x. So let's go through the formula and see how to do it. We can see here that we've got x in two spots here, and our main goal is to get all the x's together on one side and everything else on the other side. So keeping that in mind, the first thing I want to do is I want to get rid of this fraction because one of our x's is on this denominator. We're going to have to get that x up to the top somehow. And the way we do that is to times both sides, like we normally do with fractions. We times both sides by this denominator. Okay, so what we're going to do is we're going to times this bottom bit, and I'm going to hold it in brackets because there's two terms. We're going to times this side by 7 minus x over 2, and I'm going to times this side by 7 minus x over 2. And I'm going to keep them in brackets here because we've got two terms. What's going to happen over here is we know that these are going to cancel out because of cross-cancelling. They're diagonal, so they just cancel out. And we're going to be left with 2x plus a half equals 1.5, and I don't need to write the times here, it's invisible, 7 minus x over 2. What's key here is to remember that we don't want to deal with mixed numerals, here, like here, 1.5. I want to deal with improper fractions every time I'm dealing with maths. Okay, so remember, whenever you see mixed numerals, which is when it's not an improper fraction and it's mixed up like 1.5, we want to express it as 3 over 2. We want to keep them as improper fractions. So I'm going to rewrite this bit as 2x plus a half equals 3 over 2, 7 minus x over 2. And what I'm going to do next, because I can't bring anything over yet, because these are still tucked away in the bracket, I'm going to expand the bracket with 3 over 2. So I'm going to be timesing 3 over 2 by 7, and then timesing 3 over 2 by negative x over 2. So let's rewrite out this side. 2x plus a half equals 3 over 2 times 7. We know we just times 3 times 7, which is 21 over 2, because it's like 3 over 2 times 7 over 1. And we do the same over here. 3 times x, we always times straight across when we're timesing fractions, which is 3x over 2 times 2, which is 4. Okay, our next step is obviously we want to get all these x's together and we want to get all the numbers together. So first of all, let's collect the numbers. And I'm going to bring the numbers, of course, to this side because I can see here that this is a negative x term and we want to deal with positive x terms. So we'll be bringing this term over here. So we're going to bring this fraction over here. So I'm going to minus a half from both sides, and I'll just put it on the end here. Okay, so these cancel out. And now I've got to do 21 over 2 minus 1 over 2, which is 20 over 2. And I'll just write that up here. So we've got 2x equals 20 over 2, because 21 minus 1, which is the same as 10. 20 over 2 simplifies to 10. And we've still got minus 3x over 4. What do we do next? We have to take the 3x over 4 to the other side. So we're going to plus 3x over 4 plus 3x over 4. So over here we've got 2x plus 3x over 4, which equals 10. Now we've still got a fraction here, and I could have dealt with this a bit earlier if I wanted to, okay? So remember, you can always aim just to get rid of all the fractions first thing. I've left this one a little bit later because you can, and because we could have just dealt with the numbers more easily before we had to do that. It's only now I have to do that. If I want to add these x's together, I've got to give them a common denominator. And what we're going to do, because we've got this denominator, we're just going to get rid of it by timesing everything in this equation by 4. And that's how we get rid of it. So I'm going to times this by 4 because that's going to cancel that out. I've got to times this by 4 and I'm going to times this by 4. That leads to us going 8x, 4 times 2x, plus 3x. Remember, this one doesn't change because it was dividing by 4. So now it's just 3x times 1 and it's equal to 40. And then we get 11x, 8x plus 3x equals 40, which gives us x over 11 because it's 11 times x. We divide both sides and we get x equals 40 over 11. Okay, so to run back through the steps, first of all, we got rid of the big denominator because we don't like to deal with fractions when we're doing equations or any type of maths. We always try and get rid of the denominator, so we times both sides by that denominator. I then expanded the brackets. Then I moved all the numbers to one side and moved the x's to the other side. And then I got rid of any remaining fractions by timesing every term by the denominator. And then I just added the x's together and solved the rest of it. And that's all you have to do with that one. Okay, the last question I'm going to show you here is how to change the subject with some of these harder fractional equations. So let's look at a question that has 1 over 1 plus 1 over x plus 1, which equals a. And it wants us to make x the subject, okay? And I'll put that up here. Make x the subject. Right now, the subject is a. A is the thing on its own on one side, so we call that the subject. Okay, so what's the first thing we do? Well, we just talked about getting rid of fractions. We never want to deal with fractions unless it's our final answer. So I want to get this x here by itself. Right now, it's at the bottom of a fraction, and then it's at the bottom of another fraction. Okay, so first of all, when you have a fraction on a fraction, what we're going to do is we're going to make this denominator of the bigger fraction here, all of this, I'm going to give that a common denominator to start with, okay? So let's see what that means. Well, we've still got the 1 over, that's our big denominator. And I'm going to make x plus 1 the common denominator down here. And that means I've times the 1 by x plus 1. So again, x plus 1 over x plus 1 would have equaled 1. So it's exactly the same. I'm just giving them a common denominator on this bottom part of the fraction. Okay, and then I've got plus 1 still. And we know that all equals a. Okay, I'll go up here. So adding these together, we get 1 over x plus 2 over x plus 1. Now remember, this is a smaller fraction here, as it was in the question. So we've got to distinguish, or we've got to make sure it's clear that this one's our big fraction, this one's our small one, which equals a. What I can do now is, because this is the bottom, this is the denominator of the big fraction, I just simply have to times both sides by this bottom denominator. So I'm timesing this bigger fraction by x plus 2 over x plus 1, which is going to cancel that out. And I'm going to times this side by x plus 2 over x plus 1. And that's going to give me 1 equals a x plus 2 over x plus 1, just timesing across here. We know that this is a over 1, so this is going to times the denominator there. What I'm going to do next is I'm going to get rid of this denominator now by timesing both sides by x plus 1. Times x plus 1, and I'll put it in a bracket because we're taking two terms here, so always keep them in a bracket here because we need to times them together. These are going to cancel out, so I get 1 times x plus 1, which is just x plus 1. If this was another number besides 1, you would have to times that number by x and then 1. You would have to expand the brackets normally. Here we are expanding, but it just ends up being itself because it's 1. So we get x plus 1 equals a, and I'm going to expand this out. A times x, ax, plus 2a, a times 2. And then I'm going to get all the x's together. Remember, that's always our aim. I want to make x the subject, so I've got to get all these x terms on the one side. So I'm going to pull this over here by minusing it. Okay, so we're going to minus ax from both sides, so that gets rid of that. And I'm going to minus ax over here. So now we get x minus ax. And the plus 1 was here. And because I've just taken the x's here, I want to take that plus 1 over to the other side as well. You can do this in 2 steps, but I'll just do it in 1 for you. Okay, so it's x minus ax equals 2a minus 1, because I pulled the 1 over here and I brought the ax over here. What I do next is I have to collect these x's together. I don't want to know what x minus ax is. I want to know what x is, so I factorize this. I get x, 1 minus a equals 2a minus 1. And we're going to get a final answer here. And I'm going to write it back up here. We're going to get, because I just want to know x, I can divide off both sides by 1 minus a. So I'm going to get x equals 2a minus 1 over, and I'll just make this a bit smaller, 1 minus a. Okay, so that's how you solve a fractional equation.